Welcome, ladies and gentlemen, to your MN43 notes, where we're going to talk about the circumference and arc length of circles. This is section 11.4 in your textbook. And I know you've all talked quite a bit about circumference in the past, and also we've talked about it in this class, where the circumference for the formula is pi times diameter. If you have the radius, of course, you would go 2 times the radius times pi to get the circumference. But this is the formula we like to talk about. And then the circumference true definition is the length or distance around a circle. So it's kind of like the circle's perimeter, if you want to think of it that way. Okay, example 1, it says find circumference with radius n equals 9 centimeters. Now here's the difference. It says find the exact amount and also the approximate. Approximate is the rounded answer. That's kind of what we're kind of used to. So let's first start with the formula. Circumference equals pi times diameter. We're given that the radius is 9, so the diameter in this case is 18. So we put that into our formula, pi times 18. And in your calculator, you can please use the pi button. Don't use 3.14. Use the pi button. And when you use the pi button times 18, you'll get 56.55 centimeters. So 56.55 centimeters. This is the approximate because you had to round it. Anytime you use the pi button, you're going to end up rounding it because pi, of course, is irrational, which goes on forever and ever. So if you want an exact answer without any rounding, you cannot approximate the number pi, so you would leave it as 18 times pi. So 18 times pi centimeters is the exact answer for the circumference of a circle with a radius 9. So exact versus approximate. In exact, we use that a lot in the Explorin and EPAS, the ACT test. You'll see it in that form. So it is exact. It actually ends up being easier leaving an exact form, but I know it's a little foreign initially. Now here right here, I'm gonna actually give you a formula eventually for finding an arc length, but rather than do that initially, I'm gonna come down here and show you first how to actually find the length of an arc. So there's a typo here. It says find the length of arc GH. So I wanna know the length. So if I take a piece of yarn and follow this curve, and end it right here and then straighten it, I want to know what length that is. And the easiest way for me to demonstrate how to do this is by using proportional reasoning. We know this central angle is 120 degrees, which means that arc measure out there is also 120 degrees. Remember, this is a central angle, not an inscribed angle. So it's 120 degrees over the degrees all the way around a circle, which is 360 degrees. And that will be proportionally related to this arc measure, which we don't know, or not, excuse me, I said arc measure, but I meant length of arc, GH. So I'm going to put that as X over the circumference all the way around the circle. So again, we're going 120 degrees, which is the measure of the arc, over 360 degrees, which is the total degrees around a circle, equals the arc length over the total circumference, which is pi times diameter. Now we have a radius of 11, the diameter equals 22. So again, this is the arc length that we're looking for. And this right here is the circumference of the circle. Okay, so to solve any kind of proportion, we've done it a million times. We cross multiply, so 120 times pi times 22, which is going to equal 360 times x. So if you go 120, use the pi button, times 22, you end up with 8,293.8, which is equal to 360 x. Divide out 360, you'll get that your radius, excuse me, not your radius, your length of your arc is 23.0 centimeters. So the length of the arc is 23 centimeters. And now kind of taking a step back, let's go up here and you actually create a formula. And this should be a circle over here on the right-hand side, but the formula is that you want to find the measure of AB, arc AB, is right here, which is the angle, or the degree, over 360 degrees, equals the length of AB arc over circumference. Oops. Okay, so that is the formula if you want to use an idea of a formula, but really it is just proportional reasoning, part out of whole. So the last example here, in this example 3, I want to actually find the circumference, which makes it a little bit different. But with that same idea in mind, where here, you notice we have an arc measure, or this angle measure right here. We have the length of this arc right here, which is 4.19 inches. So the only information we're missing really is the circumference. So let's set her up. So we have 48 degrees for the arc, divided by the circle's degrees all the way around, which is 360. So that goes, it's the same over and over. So it's the degree of the arc over the degree of the circle equals the arc length over the circumference. And that's the part we don't have this time. And I do want you actually to take a step back here at example number 3 and find the circumference, and I want you to also find the radius here, and that does help with the homework a lot. Okay, so let's again reiterate. We have 48 degrees as the arc measure over 360 degrees equals the arc length 4.19 over the circumference. You cross multiply, so you have 48c equals 360 times 4.19. It's going to be 1,508.4. You divide out by 48 to solve for C, and you end up with a circumference of 31.4 inches. Now, that is great to know the circumference, because now you can work backwards to find the radius. So over here, it says to find radius. This is where sometimes students have difficulty, so this is kind of important to make sure that you put this in your notes very clearly. Okay, and to find the radius, now that we have the circumference, we want to use the circumference formula, C equals pi times diameter. We know that the circumference is 31.4 inches, so I put that, substitute that into the formula. And really, you can see that to solve for diameter, you're just dividing by pi. And you know, even before of course, I'm doing this very algebraically. But if you can see to work backwards that you're going to take circumference divided by pi, obviously you wouldn't have to set up this formula. But 31.4 divided by pi ends up giving you a 10-inch diameter. And once you have that, you can divide that by 2, of course, to find the radius of 5 inches. And that's the other answer we want. Okay, so again, the whole purpose of finding, or not purpose, excuse me, the whole method for finding arc length is using proportional reasoning. We're using your arc measure over 360 degrees equals your arc length over the circumference. And it's just doing parts out of wholes and cross-multiplying and solving it. Thank you for tuning in. I will take any questions you have on this material tomorrow. Thanks.